Hey guys, so today we're going to do a bit of a review of composite functions and just what that means. And to begin with, of course, we'll take a look at our bell work. So if you haven't had a chance to do that yet, make sure you pause the video and do that real quick. Okay, so to look at these, what we're doing is we're basically just doing some binomial expansion and or distribution. So sum it up all of it, distribution is what we're doing. Okay, so in order to do this one, the easiest thing to do is for us to expand out the x plus h, and hopefully you remember that there's that shortcut where we do the first term squared plus 2 times the middle term plus the last term squared. All right, and then the last step is to distribute that 2 in, and so we would get 2x squared plus 4xh plus 2h squared. Okay, now this next one is kind of like a problem in disguise. So the first thing I'm going to do is the thing that we often do, which is pull all of these numbers, all the coefficients, to the very front. So then I would get 6 x plus h times x minus h. And this one, hopefully you identify, is a difference of squares, because it's x plus something and x minus the same thing. When we do that, we just get the first term squared. The middle term will cancel, and so we get minus the second term squared. And then, of course, we can distribute in that 6 in order to get 6x squared, minus 6h squared. Okay, hopefully, like I said, you had a chance to review that from previous lessons. Now let's jump into what we're doing today. All right, so now what we're going to do is here we're saying that if x is equal to 1, we want to know, like, what is this function x squared minus 2x minus 1? Well, this just literally means take this 1 and put it in. It's like the simplest of composite functions because it's actually just function notation. And so you could think of it as like f of 1, right, which is the way we've written it before, and then plug in 1 everywhere there's an x, like so. All right, and then we just start working it out. So 1 squared is 1, 2 times 1 is 2, minus, because of course it's subtracted, and then minus 7. And then the last step is just to collect all of that together, and so we're going to get negative 9 plus 1, so negative 8 would be our final. So f of 1 is negative 8. Okay? Now, if we look at this next one, it's doing the same thing, but starting with that function notation instead of you having to do it on your own. It's just telling you, hey, this means x is negative 3. Okay? So we can go ahead and write that out again. Now be careful here, it's important you use brackets, because if we don't use brackets, then this isn't the same thing, right? If we have negative 3 squared versus negative 3 in brackets squared, we get two different answers, because this one is effectively negative 1 times 3 squared, which would be negative 9. Whereas if we square the whole thing, we get positive 9. And since this is, like, the x term is squared, we have to square the negative portion of it. Okay, and then we're going to get negative 4 times negative 3 plus 8. And then, like I said, we just start working that out. So negative 3 squared is 9 times 2 is 18. Negative 4 times negative 3 is positive 12. And then plus 8. So that gives us, when we put that all together, 38. So f of negative 3 is 38. All right, so next one here is a practice. So like I said, as before, take a second, pause the video, give it a try, and then you come back and unpause it, and I'll have the answer here for you. All right, so hopefully you had that chance. And so this one is just telling us to plug in 2 for x. That's what f of 2 means. And so we're going to get negative 5 times 2 squared plus 4 times 2 plus 1. All right. So this is going to be 2 squared is 4 times negative 5 is negative 20. 4 times 2 is 8, and then plus 1. And that gives us negative 11. So f of 2 is negative 11. All right, now we get back into some examples, and this time it's going to get a little bit trickier. Okay, now this is a very important term, and you're going to understand why when we get into doing calculus proper and start with our limits. This is going to be a very important function, f of x plus h. But remember, all this means is the same as it did before, and that's that whatever is inside these brackets, we're going to replace all the x's with it. So this one here just becomes x plus h all squared. Okay, and then of course we already did this problem, so we can very easily get first term squared plus 2 times the middle term plus the last term squared. Because, well, like I said, we literally did this back at the beginning. This was, oh, you know what? Where was it? Here, there it is. Right? We did it in the bell work. Okay? So we multiply that all out and we just get x squared plus 2xh plus h squared. All right. Now the next one, this is also going to be important, but for different reasons, but it follows the exact same pattern again. So what we're going to do is replace all of those x's in the formula or in the equation with 1 plus h. So again, just be careful. This is 2, and then x get replaced with the entire thing squared minus, again, always use brackets. It just helps you not make mistakes here. 1 plus h. All right, now we need to expand that out. So this one is fairly easy because it's that perfect square again. So 1 squared plus 2 times the middle term, which is going to be 2 times 1 times h, or 2h, plus the last term squared, so plus h squared. Now here, I'm going to distribute this negative 1 to make it easier for me as well. So that becomes negative 1 minus h. And then we need to distribute in this 2 as well. So we'd get 2 plus 4h plus 2h squared minus 1 minus h. And then our last step is going to be to put all that together here. And let's start by putting the highest degree first, so 2h squared, just because we're used to it. Now here I'm going to use a highlighter to kind of help us out. So here we can see there's a 4h and a negative h. So that's going to combine to be 3h. And there's also a 2 and a negative 1. So we're going to put those together as well and get plus 1. And so f of 1 plus h is going to simplify down to give us 2h squared plus 3h plus 1. All right, so once again, we've got a practice here, so pause the video and give it a chance, or give it a try. All right, so hopefully you had that chance to give that one a try. And now you've come back and you're going to see if you got the answer right. So f of 2 plus h means, again, that we replace all of these x's with 2 plus h. So that's going to be 2 plus h squared plus 2 plus h. So for squaring this out, we get that first term squared plus 2 times our middle term, so 4h, and then h squared plus 2 plus h. This time it's easy because we're not distributing in a negative, it's just plus 2 plus h. All right, then we're going to combine our like terms, starting with our highest degree. And then I've got a 4h and an h, so that gives me the 5h. And then I've got a 4 and a positive 2 here, and that gives us plus 6. So f of 2 plus h should have given you h squared plus 5h plus 6. All right, so let's do another example here where things get a little bit more complicated because now we've got a full trinomial that we're substituting in that x plus h. You can see that x plus h is definitely important. That's why I keep getting you to practice it. All right, so this is going to be 3 times x plus h squared plus 5 times x plus h minus 1. And then we just need to go ahead and do all of our distributions in that. So first x plus h squared, so that's x squared plus 2 times our middle term of 2xh, and then plus h squared. Now I'm going to distribute the 5 in right away here, so plus 5x plus 5h minus 1. And then I'm going to go ahead and distribute in this 3 as well. So I get 3x squared plus 6xh plus 3h squared plus 5x plus 5h minus 1. And then we put all the like terms together. Our x squared goes first. Then I'm going to go ahead and I'm going to put just my regular x, so plus 5x. Then I'm going to put my xh, so 6xh. Then I'm going to put just my h, so 5h. And then I'm going to put my h squareds, and then my 1. So what you'll notice on this one is that nothing actually combines in this one. And so we end up with just a whole bunch of terms, which is a little unfortunate, but it is the way that it should look. Okay? So what I'm going to get you guys to do now is go ahead and do that next practice question there, which I unfortunately labeled 1. It should be practice 5. My apologies. And you're going to do the exact same thing. So pause the video, give it a try, and hopefully you've come back after pausing. So let's go ahead and do that solution to make sure you got it right. And so we're plugging in that x plus h for x, so it becomes x plus h squared plus 3 times x plus h plus 8. Then we start our expansion, so x plus h squared becomes x squared plus 2xh plus h squared. Then we distribute in the 3 here, and we get plus 3x plus 3h plus 8. And then we just put it all together, and again, you can see that nothing actually ends up combining here. These are all separate terms. So really, we don't have to do anything. We could rearrange it, but ultimately, if you realize that nothing does combine, it is okay with just stopping at that point and saying, hey, that's my answer. Okay, because the order that this happens is not important. We usually will put the highest degree at the beginning of, like, especially of x in most of our cases, but it's not necessary. It is still going to be true. All right, guys, so after that, then you can move on to the formative and work on that. As always, the answer key is posted online, so you can go and check that out to make sure you got all those right as well. And yeah, good luck with it all.